we have an application endpoint, and that is associated with a web server. It captures the logs and then it submits the logs in a storable manner in Elasticsearch storage. We also have Kafka topic here that relates the producer and the consumer sides. So at the consumer side, we have to consume the raw logs that have been captured by the application and to cleanse it and to make it in a readable form or a user-friendly form to present it on the Kibana dashboard. So this is the flow in the nutshell. We have also captured the flow and some details in the well-documented PDF attached with this assignment summation, and we will be capturing the link of the video along with this voiceover. This is how the backend looks like. We have the ELK stack here, Elasticsearch, Logstash, Kibana, and in Logstash we are using FileBeat as an associate to capture the logs from the application running. On the application side we have application py, and application consumer side we have app-consumer.py. And to host app.py on a web server, we are taking help of Flask framework here because it provides a very good web server architecture. And this is the consumer side that will be associated using Kafka pipeline, Kafka topic. This is Kafka producer and Kafka consumer we are talking about, just to show if it has been associated properly. Let's check the message. Sometimes back we passed high and we received high on the consumer side. Moving on to app.py on the code side. So we try to mimic the weather application here that captures the meteorological information about the weather, humidity, precipitation and all the other factors. Here we will be keeping the architecture simple and generating the humidity raw logs that will be consumed by the consumer side. And if we say raw logs, that means it will be capturing various information like timestamps, the machine details and all. But on the consumer side, as we know, we won't need all those factors. What we are interested in is the timestamp and the corresponding humidity. So we have to do some cleansing process here. And as you see, we have in app consumer py a good connectivity of the Kafka topic and Elasticsearch reconnection to save and persist the logs here. This is how on the ELK stack we can see the events in the real time. On the index side we have Kafka index and process message index, and these are the data streams that we talked about, including the file beat. On the Elasticsearch front we can check the process messages. As we just talked about, we are interested in timestamp and humidity, while if we talk about the raw logs, they are quite very detailed and might not be all essential for the Kibana dashboard, or I mean to say the user-friendly dashboard that is our end goal. So we will be using this query. We can use the pattern matching of all the records, and those records are the keys and the identifiers based on which the entire message will be fetched from the topic from the Elasticsearch index, and that identifier will be passed to the producer side from the consumer side via Kafka topic. Moving on to the backend flow. So as we can see, on the consumer side we are consuming the entire log here just with the help of a key identifier that we just passed. Now here comes the main action part of the backend, how we want to present the process data to the end user. We are taking help of Kibana here to generate user-friendly graphs, a readable graph, to convey this scenario, like how the humidity value has been varying with timestamp. We assume that bar chart will be a good depiction, so that's where we decided to go ahead with the bar charts. And this is an example of a short interval. As we can see, we can try to analyze a pattern of humidity, whether it is increasing or decreasing in a given time range, just to come up with an overall picture if we can predict a rainfall or any sudden increase in the humidity of the air. So not only this, we will also leave the system running for some time and fast forward the recording, just to show over a considerable period of time how the graph looks like, how it can help us in pattern analysis, how it can help us in trend analysis. So now we are leaving our backend system running, and we will capture the logs for some considerable duration. All the logs are getting pushed after an interval of 1 minute, but since we have fast forwarded this recording, we do not have to wait for this long. Our data should be ready for front end now. Let's see, considering the latest timestamp. So this is how it looks like. What we are mainly interested is understanding a pattern. So if we see the latest entries per the latest timestamps, we can see a decline in the humidity value. That means the application humidity analyzer or application endpoint basically has sent the logs showing that there is a reduced probability of rainfall. This is what we have designed as part of log analytics. Thank you.